Look up at the roof of a modern house, and you will likely see sleek black solar panels soaking up the afternoon sun. Those shiny rectangles get all the glory, the massive advertising budgets, and the neighborhood envy. But if you were to bypass the rest of the system and plug your expensive flat-screen television directly into those panels right now, it would instantly fry the internal electronics and ruin your television forever. Most people spend tens of thousands of dollars on a solar setup, completely obsessing over which brand of panels to buy. Yet they totally ignore the heavy, silent metal box bolted to the side of their garage. Without that unassuming box known as the solar inverter, your entire rooftop setup is practically useless. It is the hardest working component in your entire home, acting as a master translator, an uncompromising safety guard, and a financial efficiency wizard all at the exact same time. If you are thinking about going solar, or you already have panels and want to know how you are actually powering your coffee maker with pure sunlight, you absolutely need to understand this machine. Today, we are going to look inside that heavy metal box, avoid the confusing engineering textbooks, and break down exactly how a solar inverter works step by step, so you can finally understand the brilliant brain behind your renewable energy. To understand why an inverter even exists, we have to talk about the two completely different languages of electricity. When sunlight hits your solar panels, the silicon cells get excited and start pushing electrons in one single continuous direction. In the world of physics, this is called direct current, or DC. Think of DC electricity like a calm, steady river flowing smoothly in one straight line. Batteries, flashlights, and your smartphone all run on this steady flow of DC power. But your house does not. Everything plugged into your wall outlets, your refrigerator, your microwave, your air conditioner, runs on a completely different type of power called alternating current, or AC. Instead of flowing in a straight line, AC electricity constantly changes direction, washing back and forth like the crashing waves on a beach, usually 50 or 60 times every single second. If you try to feed the straight-line DC river from your roof directly into the crashing AC waves of your sensitive home appliances, absolute electrical chaos happens and things catch on fire. The solar inverter's absolute main job is to act as the ultimate real-time translator, converting that unusable DC river into the perfect, usable AC waves your house desperately needs. So, how does this heavy box actually perform that translation? If you open up the inverter, you will not find any spinning gears or moving mechanical parts. Instead, you will find a highly complex circuit board loaded with heavy-duty solid-state switches, usually made from advanced silicon or silicon carbide. These microscopic electrical gates are the true heavy lifters of the system. When the straight-line DC electricity flows down from your roof and enters the inverter, these switches rapidly open and close in a highly synchronized pattern. By violently flipping the path of the electricity back and forth thousands of times, the inverter artificially forces that straight-flowing river to start reversing direction. It essentially chops the DC power up and flips it to perfectly mimic the back-and-forth crashing waves of AC power. However, this initial translation is incredibly rough and blocky. If you looked at this newly created AC power on a testing monitor, it would look like sharp, jagged, pixelated stairs. If you fed that jagged electricity into your sensitive home computer or your television, it would cause massive audio buzzing, screen flickering, and eventually destroy the delicate internal power supplies. To fix this, the inverter pushes this rough electricity through a series of specialized magnetic coils and capacitors. These components act exactly like shock absorbers on a car, filtering and smoothing out the harsh, jagged corners until the electricity forms a beautiful, smooth, rolling curve known as a pure sine wave. By the time it leaves these internal filters, the power generated by your roof is literally identical to, and sometimes even vastly cleaner than, the electricity you buy from the massive city power grid. But a modern solar inverter is much more than just a dumb translator. It is actually a highly intelligent computer constantly trying to maximize your financial investment. Throughout the day, the sun moves across the sky, clouds roll by, and shadows from trees temporarily block your panels. Because of this, the amount of voltage and current coming from your roof is constantly fluctuating wildly. To handle this chaos, the inverter uses a brilliant piece of software called Maximum Power Point Tracking, or MPPT. The MPPT acts like a professional race car driver constantly shifting gears. It scans the electrical output of your panels hundreds of times a second, continuously adjusting the internal electrical resistance to find the exact perfect sweet spot where the voltage and current multiply. to give you the absolute maximum amount of total wattage. Without this software, a passing cloud could cripple the efficiency of your entire roof, but the inverter adjusts instantly, making sure you squeeze every single drop of usable energy out of the available sunlight. Depending on how your specific home is set up, this entire translation process might happen in two very different ways. The most traditional setup uses something called a string inverter. In this system, all the panels on your roof are wired together in one long chain, like old-school Christmas lights. The raw DC electricity from the entire roof flows down a single wire into one large inverter box bolted to your garage wall. It is highly cost-effective and easy to maintain. However, just like those old Christmas lights, if a heavy shadow from a chimney covers just one single panel, the power output of the entire chain drops drastically. To solve this, many modern homes now use microinverters. Instead of one giant box on the wall, a tiny miniature inverter is bolted directly underneath every single individual solar panel on the roof. Each panel gets its own personal translator and its own MPPT brain. This means that if one panel gets covered in shade or dirt, it does not affect the rest of the roof at all. The translation from DC to AC happens right there on the shingles, and the clean AC power flows straight down into your breaker box. While they are a bit more expensive up front, microinverters are an absolute game changer for houses with complicated roof shapes or lots of towering trees. Finally, we have to talk about safety and sharing. Most home solar systems are directly tied to the city power grid. This means your inverter has to perfectly synchronize its homemade electricity with the massive power plants running your city. Before it pushes a single watt of power into your electrical panel, it listens to the rhythm of the city grid and precisely matches its own frequency to it, like a musician joining a perfectly timed orchestra. If you generate more power than you are using in the middle of a sunny day, the inverter safely pushes that extra electricity backwards through your meter, literally spinning it in reverse and sending power out to your neighbors, which earns you valuable financial credits on your electric bill. But more importantly, it acts as a massive safety guard. If a heavy storm knocks out the city power lines, your inverter instantly detects the blackout and completely shuts itself down within milliseconds. This is a critical safety feature called anti-islanding. It ensures that your solar panels do not accidentally pump high-voltage electricity back into the dead city wires, while unsuspecting utility workers are out there trying to fix the lines. When you look at the complete picture, you realize that the panels on the roof are just the raw muscle, while the inverter is the brilliant multitasking brain running the entire operation. It translates incompatible energy, smooths out dangerous voltage spikes, optimizes your solar harvest in real time, and keeps the city grid totally safe. Understanding this silent, heavy box takes the mystery out of renewable energy and proves exactly why a high-quality installation is worth every single penny. If this breakdown helped you finally understand your home energy system, hit that subscribe button. Give this video a quick thumbs up and leave a comment below telling me if you currently have solar panels or if you are planning to get them soon. Thanks for watching and stay powered up.